Hello, everyone. Today we are going to be learning 7.3, which is graphing quadratic functions. We're going to be graphing quadratic functions from standard form. The standard form of a quadratic equation is y equals ax squared plus bx plus c. That is the standard form. In the standard form, c is the y-intercept. So the y-intercept for a quadratic equation in standard form is the c term. Let's find the y-intercepts of the following. Y equals x squared minus 4x minus 5. Well, a is 1, b is negative 4, a, b, and c. And your c term is negative 5. So your y-intercept is negative 5. Yep, it's that simple. Sometimes you want to look out in number 2, the y is not by itself. So it's not in y equals ax squared plus bx plus c format. The 6x is on the wrong side. So in this case, just like linear functions, we need to move some things around to make sure it's in the right form and also put it in the right order. So that y is equal to x squared minus 6x plus 9. And again, C is your y-intercept. So your y-intercept is 9. Go ahead and identify the y-intercept for number 3 and number 4. Pause. All right, now that you are done, the y-intercept is 5. A is going to be 1. Your B term is 0 because there's 0x. And then your C term is 5. For number 4, A term is 16. Your B term is positive 6. And your C term, there's nothing here, is 0. So the y-intercept is 0. All right. So in order for us to graph the quadratic function from standard form, we are first going to have to find the axis of symmetry so that we can find the vertex, use the y-intercept, and then put them on the graph. So step 1, we're going to graph y equals x squared minus 4x minus 5. This is what we are graphing. It is the quadratic in standard form. So I'm going to have to find the axis of symmetry. Go ahead and find it because we have done this already. So the axis of symmetry, the A term is 1, the B term is negative 4, and again, the C term is negative 5. The axis of symmetry is x equals negative b over 2a. And then we just substitute. So the x is equal to negative 4 over 2 times 1. So x is equal to negative 4 over 2. X is equal to negative 2. So your x is positive 2. The axis of symmetry is positive 2. Now that you know the axis of symmetry, let's find the vertex. The vertex, to find the y, we are going to substitute the x. So we know that x is 2. We're going to substitute 2 in for x. So y is equal to x squared minus 4x minus 5. Y is equal to 2 squared minus 4 times 2 minus 5. And again, the x we know from the axis of symmetry. So y is equal to 2 squared, which is 4. minus 4 times 2, which is 8, minus 5. So y is equal to 4 minus 8 minus 5, and that's going to give us negative 9. So my vertex is 2, negative 9. My y-intercept, easy. I can figure out it's negative 5. So let's go ahead and put those on the graph. I know that my vertex is at 2 and 9. 1, 2, and 9. Oh, sorry, 2, negative 9. 2 and 2 and negative 9. That's down here. That's my vertex, 2 and negative 9. And then my y-intercept is at negative 5. My axis of symmetry, I know, goes through the vertex. So now that I know my y-intercept is at negative 5, I need to reflect it across the axis of symmetry. So if it's 2 units away, it's going to be 2 units away on the other side. I have the basis for my parabola. To get an extra point, if you would like it, you're going to pick another domain, another x value. Now, I would probably pick 1 or 3 because it gives me a point between those two. Or I would pick -1 is a good choice, or 5 is a good choice. You have options. I'm going to go ahead and pick 1 because it's easy. So I want to know what is y when x equals 1 because I picked a domain. So y is equal to x squared minus 4x minus 5. And it's going to be very similar to what I'm doing for the vertex, only now my x I picked from the graph as my domain. So y is equal to 1 squared minus 4 times 1 minus 5. And then I just evaluate y equals 1 minus 4 minus 5. And so y is equal to -3 minus 5. Y is equal to -8. So when x is 1, y is -8. That's how I get that coordinate. When x is 1, y is -8. Boom. And then I reflect it. There goes a nice pretty parabola. Let me make my U curve. Ta-da. I have graphed it. All right, now I want you to graph the next one. But before we do that, I also want you to see that this is not in standard form. They gave you y. They want you to graph y plus 6x equals x squared plus 9. If this is cut off, just go ahead and write it in. And then you want to realize that the y is not by itself. So it's not a function yet. You have to readjust it, meaning you have to move the 6x. So you would minus 6x on both sides so that y is equal to x squared minus 6x plus 9. And this is what you will use to graph. So go ahead and pause. Find the axis of symmetry, vertex, y-intercept, put it on the graph, get the extra point, and finish graphing. Right, now that you are back, let's go ahead and work it out. So the axis of symmetry, I want to know what my A is. My A term is 1. My B term is -6, and my C term is 9. So the axis of symmetry, x is equal to -b over 2a. X is equal to -6 over 2 times 1. So my axis of symmetry is equal to -6 over 2. My axis of symmetry is equal to +3. Now that I know the x, my axis of symmetry, I'm going to substitute it in to find the vertex. So for the vertex, I know that y is equal to x squared minus 6x plus 9, and x is 3. So y is equal to 3 squared minus 6 times 3 plus 9. So y is equal to 9 minus 18 plus 9. That means y is equal to 0. The coordinate for the vertex then is going to be my x, which is 3, and my y, which is 0. So my y-intercept is 9. So my vertex is going to be here at 3, 0. My axis of symmetry goes through the vertex. Draw it so you know where it's going through. My y-intercept is +9. And if I reflect that across the axis of symmetry, because it's symmetrical, 1, 2, 3 units, 1, 2, 3 units, I'm pretty much okay for my graph. I may want another point. And so, again, I like to pick a nice, easy one. Let's find out what it is when x is 1. You know what? No, let's go with 2 so we know we could use a different number. Let's find out what is the range, or what is the y value when x is 2. So y is equal to x squared minus 6x plus 9. Y is equal to 2 squared minus 6 times 2 plus 9. So y is equal to 4 minus 12 plus 9. And so y is equal to 1. So when x is 2, y is 1. When x is 2, y is 1. And then we would reflect that across the axis of symmetry. And here's my parabola. I would have a minimum because it's the low point. My vertex, my axis of symmetry, it would be decreasing on this side and increasing on that side. So it would be decreasing where x is less than 3, and it would be increasing when x is greater than 3. Domain, all real numbers. Range, y is greater than or equal to 0, etc. All right, now let's put it in the context of a word problem. All the football players, this is very applicable. All right, so it says the height in feet of a football can be modeled by the function f of x equals -16x squared plus 64x. So they gave me an equation where x is the time in seconds after it is kicked. Find the football's maximum height and the time it takes the football to reach this height. Then find out how long the football is in the air. So what you want to do is think, conceptually. There is a football and it's being kicked. If it's being kicked, it has to start on the ground. That's where it's 0. And then it's going to go in the air. But after it goes in the air, it's going to fall back to the ground. So football gets kicked, goes in the air. Hold on. My pen is not working. I'm waiting for it. The football get kicked, ball goes in the air, ball's gonna reach a maximum height, and then ball's gonna come back down and hit the ground. All right. The maximum height is therefore going to be the vertex of whatever this is. So here's the function. They want to know what is the maximum height and the time it takes for it to reach this height, and then how long it's in the air. All right, so the maximum height that it gets to has to be the highest point. That highest point is the vertex. That's what we're looking for. So we have the function, let's see, f of x, and that's equal to negative 16x squared plus 64x. That means my a term is negative 16, the b term is 64, and my c term is 0, which makes sense because it has to start on the ground. No height, y is 0. Nonetheless, in order to find the maximum height, we are looking for the vertex. How do we find the vertex? It is the axis of symmetry substituted into the y. So x is equal to negative b over 2a. That's the axis of symmetry. X is equal to negative 64 over 2 times negative 16. So we have 2 times negative 16. We have x is equal to negative 64 over negative 32. So x is equal to negative 64 divided by 32, negative 2. So x is equal to positive 2. If x is equal to 2, to find the vertex, we're going to substitute 2 into the same equation. So y is equal to negative 16x squared plus 64x, and x is 2. So y is equal to negative 16 times 2 squared plus 64 times 2. Y is equal to negative 16 times 4 plus 64 times 2, which is 128. So y is equal to negative 16 times 4, which is going to give us negative 64 plus 128. And so y is equal to 64. So our vertex is at 264. Okay, that means we have to adjust our graph. Our vertex is going to be at 264. Let's go by 10, 30, 50. Uh-huh. And then that's going to give us 264, 50, 64, somewhere right about here. Is my vertex at 264. And the axis of symmetry goes through the vertex. And we know that the y-intercept is 0. And I reflect it is going to come right here. So because this is a word problem, we have to be careful. Our domain is no longer all real numbers, and there will be limitations. I can't go negative because if I was going to go negative, what I'm saying is the ball is underneath the ground, right? This is the ground that the ball starts on. That's what that 0 means. Ball starts, ball gets kicked, ball goes up in the air, ball comes down and stop. If I go into the negative realm, I'm going underground. And if I go into the negative realm here, I'm going into negative time. So now there is a definitive domain range, and where you're going increasing or where you are decreasing. So now I know that it says find the football's maximum height. What is this saying to me? The highest point is 64. So the highest this ball will go, the maximum height, is 64. 64 feet. Does it say feet? Oh, height in feet. So yes, 64 feet. And then they want to know, how long does it take the football to reach this height? Well, for it to get to the vertex, t is time, it's going to take us 2 seconds. 264, 0 to 2, that's 2 seconds. So the time it takes to reach the height is 2 seconds. But now they want to know, how long is the football in the air? Well, football went up 2 seconds to reach its maximum height. Football came down another 2 seconds to reach the ground. The total air time was 4 seconds. Total time is 4 seconds. And we've answered all the parts. When we're dealing with a word problem, we're going to have to be careful. What are they asking for? Answer what they're asking for and make sure it's correct in the context that it's in. All right, that's it. Quick and easy. And I will see you tomorrow.